broadcast is now starting. All attendees are in listen-only mode.
Hello, everybody, and welcome to the GALA webinar series. My name is Manuela Noske, and I'm the Communications Manager here at GALA. GALA is a global nonprofit trade association supporting the language industry. We're headquartered in Seattle, Washington, in the United States. And today we're going to have a presentation by Spence Green from Lilt. And we're so pleased that each of you joined us from various locations all around the world to participate in this event. I will hand it over to Spence in just one moment, but first I have a few housekeeping items to go over. We have muted everyone's lines to cut down on any background noise. If you experience any technical difficulties, you can let me know by using your chat box, and I will work with you to troubleshoot them. If you have a slow internet connection, your audio may be disrupted. If that happens, you can use the number listed on the GoToWebinar panel to call in using your own phone. We are making a recording of this presentation, and you will be able to find it following the presentation on GALA's global website. All participants will receive a link. Spence will answer your questions at the end of the presentation, but please feel free to type them into your chat box throughout the webinar to get them into the queue. We will get to as many questions as we can with the time remaining at the end of the session. Before we begin, I'd like to take just a few moments to introduce our speaker. Spence Green is the CEO at Lilt, a San Francisco-based startup that builds intelligent software to augment translation for the enterprise. Spence graduated from Stanford with a PhD in computer science. His research area focused on the intersection of natural language processing and human-computer interaction. He has published papers on statistical machine translation, statistical language parsing, and mixed initiative systems, and has given talks on translator productivity. Spence will also speak at the upcoming GALA conference in Munich at the end of March, where he will explain why we will always need translators in our industry who are domain experts. Consider joining us for that in Munich. So now, without any further ado, I'm going to hand it over to Spence for the remainder of the session. Spence, the floor is yours.
Thank you, Manuela. Thanks so much. Hello, everyone. Thanks for joining this morning. Happy Valentine's Day. If you forgot, you still got time. So I hope everybody's on that. Today, this is going to be a little bit a different talk than I've given in the past. I'm going to try to give a talk from the perspective of somebody deciding whether to use machine translation and machine learning in their localization workflow from kind of an executive's point of view. I'll try to draw an analogy between buying a similar business function to localization and sort of compare and contrast the two. But what I want to start with is why now is a time to consider using automation if you haven't before. So we'll go through a couple slides about why now is such an interesting time in language technology, and then we'll go into some considerations for buying language technology and using it to transform the way that you do localization. Okay, all right, so what is machine learning? So you'll read a lot about artificial intelligence these days. When people talk about artificial intelligence, they're usually talking about machine learning. And what exactly is that? Well, there's a simple observation that we as people, we adapt to the environment around us. We have sensor systems, we have eyes and noses and ears and hands, and we can collect information from the environment and we can learn from that information. Historically, computer systems can't really do that. We program them to basically run sorry about that, everyone. I don't know what happened there. Okay, we're back. So historically, computer systems, you program them and they basically run a sequence of actions. So they'll run a series of commands in order, and they don't really learn from the environment around them. So what machine learning does is gives us mathematical techniques for helping systems learn. Actually, machine learning, we learn this in middle school. So here's an example of a machine learning system. Everybody learns in sort of middle school algebra how to fit a line to a set of points. So in here, I have a set of points which are farm size on the horizontal axis, and say that we want to predict a crop yield on the vertical axis. And so we learn a simple regression, and we learn a slope and an intercept, and so that's this red line here, and that will fit a set of points. Everybody learns this in sort of middle school algebra. But this actually is a machine learning system. So what this does is it gives me a system whereby the input x, which is the farm size, if I put it into this equation, I get as an output a crop yield. And that's a predictive system that we can learn from data. We can go out in the world and collect data about farm sizes and crop yields, and we can build a machine learning system that will then help us predict a crop yield for a new farm size. So this is exactly what a machine translation system does. We go out in the world and we collect a bunch of
Spence, we have lost you, I think.
Manuela, can you hear me again?
No, I can hear you again. Thank you.
Okay, I just lost my audio for a second. Okay, I'm back. So we can go out in the world and collect data about translation. We can train machine translation systems. And then when we have a new sentence, our machine learning system will then predict a new translation. It's exactly the same as this simple, very simple linear regression. So what we want are software systems that adapt to data. And so machine learning today, it's really sort of indistinguishable from computational statistics. So we have these statistical models, and the computational aspect is that typically we want these models to run at a very large scale so that they can be trained on lots of data and that they can serve lots of requests at the same time. Okay. So why has there been all this news recently about artificial intelligence and machine learning? Well, there's people have been working on artificial intelligence and machine learning for decades and decades. The term was actually artificial intelligence was coined in 1956, and there have been these sort of booms and busts over the last number of decades. But now feels fundamentally different. And why is that? Well, it's really the convergence of three different trends. The first is we have sensors everywhere. All of us are carrying around phones. We use websites. We have computer systems in our cars and in all of the devices that we use. And for better or worse, all of these devices are collecting data all the time. So there's all this data being generated and all this data being stored as we walk around in the world with these devices. In particular, there's an abundance of linguistic data. So we all now use chat applications, we use iMessage, we call up call centers, and we speak to computer systems, and all of this data is logged, and this can be used for building systems. The second phenomenon is some algorithmic improvements that have taken place over the last decade. So linear regression, that's a very simple machine learning algorithm. It doesn't happen to be a very good one because it doesn't maybe there's some other factors that we want to consider instead of farm size. Maybe we want to consider what the weather is, what the geography is, who the farmers are who are working on the farm, whether they're using tractors or not. There are a lot of different factors that we want to consider, and we might not be able to build that into our linear regression system. But there has been more sophisticated machine learning systems in the form of neural networks. Neural networks are also old. They were devised in the mid-50s, but they weren't very effective until sort of maybe the last 5 to 10 years because they were very computationally expensive to train, and people didn't know how to train them in a very effective way. But there was an algorithmic breakthrough in 2006 that helped people understand how to train these systems, and coincident with that, computers have just gotten an awful lot faster. So everyone has, most computers these days have two different types of processors in them. They have a central processing unit, which is good at the sort of math I show there. This is just adding numbers together. So you add 1 plus 2 and you get 3. Over the last 20 years, these processors called graphical processing units have been developed, and they were originally developed for games so that you could, have sort of 3D graphics and so on. And GPUs are really good at vector math. So this is adding two vectors together, 0 and 1, and adding those to 2 and 3, and you get another vector, which is 2 and 4. And so that's different than the type of math that a CPU does. But it turns out that this vector math is exactly what you need to train a neural network. So people figured out about 10 years ago that you could take these GPUs that had been designed for games and you could use them to train machine learning systems. And this made the neural network training that much faster, which led to much greater progress. So really, a lot of the excitement and the advances recently have to do with the convergence of these three trends: data, algorithms, and compute. Now, let's talk about how MT has gotten better in the sort of history of MT over the last, since the late 40s, which is when MT research started. So up until about the 1980s, people built rule-based MT systems, or RBMT systems, and these were primarily devised by linguists. They would write rules. You know, this word or phrase in French translates to this word or phrase in English, and you would have these long list of rules that you would then take French sentences, match them against the rules, and you'd get translation. And those didn't tend to work very well because it's very difficult to write these rules. You've got to have a lot of them. There are a lot of exceptions. There are a lot of edge cases. And so the translation could be very good if they tended to match some of the rules. But if they didn't match the rules, then you either didn't get any output or you got bad output. So in the late 80s, early 90s, there was a research group at IBM that decided to start building machine learning systems for machine translation.
I think we've lost you again.
Lost my audio. Okay.
There you are.
Yeah, it keeps dropping in and out a little bit. I'm not sure why. I'm sorry about that. If it drops again, I'll just stop until it comes back.
Okay.
So there are these statistical word-based systems that were trained on large amounts of parallel text. So this is a sentence in French and a sentence in English. And instead of writing down rules, you could learn these rules from data using machine learning. And that was really exciting. That was the first time that people had built systems that could be learned from data. And they were better than the rule-based systems. And there was kind of a delay in the research over the 90s. The team at IBM disbanded, and it wasn't really until the late 90s that the work at IBM was re-implemented by some researchers at Johns Hopkins, and this really led to an explosion of machine translation research. In the United States, right after 9/11, the United States government decided to start spending a lot of money on machine translation. And a lot of the systems that we have now in the research came immediately out of that funding. So right after 9/11, there was the next big advance, this next sort of inflection point here, which was the advent of phrase-based machine translation systems. So probably a lot of people are familiar with Moses, which was the phrase-based machine translation system that everybody used for about 10 years. And those systems were significantly better than the word-based systems that were designed at IBM. So these new phrase-based systems would learn rules between phrases instead of just word-to-word rules, and that helped you capture more linguistic information in the model. Now, there was a lot of advance in the 2000s, and this was mostly to do with the explosion of the internet and a lot more data coming onto the web. As that happened, people figured out how to take advantage of this data and build super large-scale systems. So you started to see Google Translate come out, Microsoft Translator Hub, these big general domain systems that are trained on the entire web. There weren't as many algorithmic advances. The advances were mostly due to, or I think you could argue, had a lot to do with the amount of data that people now had access to train systems. Of neural MT systems. The first real paper came out in late 2014.
Spence, you have been gone for the last 30 seconds.
Okay, can you hear me now?
Yeah. Mm-hmm.
Okay. Okay, so I just, the last thing I said was that the neural machine translation systems really came out in late 2014, early 2015. And since then, there have been tremendous advances up to the present day. So this leads us into 2016, 2017, which is when the neural MT systems really started to beat these phrase-based systems. And there have been new architectures coming out in the last couple of years, and there's no sign of this slowing down. So this is sort of the third big inflection point in the history of MT research. Okay, so as I said, we kind of went through these 4 different phases. We had rule-based systems where all these sort of linguistic syntactic rules were written by linguists. Then we went to word-based systems, which were these, we had these word-to-word associations that were learned. And then statistical phrase-based systems, which learned associations between phrases of words. And then finally, this really complicated diagram on the bottom, these neural machine translation systems that is sort of this sort of network of this neural network architecture, which represents words and phrases in this sort of numeric way. It's not terribly important for this presentation, but is it sort of a new way of working with words. Okay. So there are 2 real key ideas in neural MT, and this is really, if you're interested in sort of the technical details, most of those aren't important if you're an executive buyer. The things that really do, if you want to come away from this thinking like, what's different about these systems? Well, there are 2 things that I think account for a lot of the gains in neural machine translation. The first is that the older systems couldn't really learn associations between words. So they would learn, they would have separate sort of representations of car versus cars. So like the singular and plural form of a word. And obviously those 2 word forms have something to do with each other, but the old systems couldn't really learn any association like that. The new systems, on the other hand, can learn not only associations, sort of these sort of word form associations, they can also learn something that looks like semantic associations. So the way they represent words, you can actually do this arithmetic. So if you take the word representation for a king and you subtract the word representation of man, and you add the word representation for woman, you get the representation for queen, which this was one of the most surprising and unexpected results. This was about 4 or 5 years ago, that you could start to learn these associations between words. And this is really, really important for translation, because one of the things we've historically struggled with is sort of inflections between verbs, and when you're trying to translate into say a really complex language like German that has these very complicated word forms, the machine translation systems would just break down completely. And we don't have that anymore, so you get this more fluent output. And a lot of this has to do with the way that words are represented in these new systems. The second big breakthrough is that these new systems are much better models of language. So the old statistical systems, when they were generating a translation, they would usually predict the next word based on the last 4 words that they had predicted. So they really were only operating on a very small window of the linguistic context while they were working. The new systems predict each word based on the entire source sentence and the entire target. So they model a lot more linguistic context, which is one reason why these new systems produce so much more fluent output than the old systems did. Okay, so that's about machine translation. How is AI being deployed in the enterprise? Well, I think you sort of see it coming in 4 different buckets. The first is productivity, and there are companies who are building systems to automate bookkeeping. So this is like, assigning a receipt, what account it goes into in a chart of accounts. There's also automation coming into manufacturing. And so this lets you do more work. This is just productivity enhancement. It lets you do more work with the same staff. There are also work being done on there are applications where machine learning systems will just give you higher accuracy than what humans can do. So machine learning systems tend to be better at fraud detection. looking across a lot of different signals to figure out when there's fraudulent activity, like say in credit card transactions, but also in expense reporting in businesses. So you've got 10,000 employees all submitting expense reports. It's really difficult to hire a bunch of people to go over all of those. So you can now have machine learning systems that will go over all the expense reports and tend to be better at finding fraud than hiring a room full of people. The third way is in process automation. You see this a lot in software testing. So before, you used to hire a bunch of people that would click around on interfaces, and now you can have machine learning systems that will do that for you. You also see it in call center automation. And the final way you see it is in decision-making systems. This is particularly in healthcare right now. A lot of people are working on this. So you will have a machine learning system that will say, take the output of an MRI machine and will indicate where it thinks there are points of interest that a doctor will then go in and look at. And this, incidentally, I think is where machine translation is going to come in and have the highest impact in localization, which is, it's for most business settings, you still can't remove the human translator. You need common sense reasoning and world knowledge and knowledge of style guides and brand voice and so on. And that's really hard to model in a machine translation system. What the machine translation system can do is give a suggestion to the translator as they're making decisions while they work. So that's how it's coming into the enterprise. What's interesting about localization is that for most businesses, it's an outsourced business function. And so if you're interested in AI and machine learning, how are you going to bring that into an outsourced business function? So that's what I want to talk about for the rest of the talk. Let's say you're convinced you want to deploy machine learning. Now you've got to decide, well, do I want to take this function and do I want to insource it? Do I want to bring localization in and start to deploy ML, or do I want to keep it an outsourced business function? And I think that's an executive level choice that people make. And when they're making this choice, they usually look at sort of three big factors. Is this business function of strategic importance? Is it a core competency of this particular business? And which is most cost effective? Is it more cost effective to insource it, or is it to outsource it? And so when I was thinking about getting ready for this presentation, I was thinking about me and the sort of the company I run. We're a startup. We're about 50 people, and there are some functions that we have that are insource functions. We're a technology company, so we have an engineering team. We don't outsource software development for the most part, although we do a little bit. But there are definitely things that we do outsource. So we outsource most of our financial function, our legal function, and in some cases for sort of partner or integration software engineering, so sort of like systems integration, we outsource some of that. And I was thinking about these functions that I manage, and it occurred to me that for most people, managing localization is a lot like managing legal. And so I thought I would use this example as I go through thinking about bringing machine learning into localization. I was thinking through how I would do that if I was managing our legal team. And maybe that's helpful. It gives you kind of a separate way of thinking about how you would go about bringing machine learning into a business function. And so localization and legal are actually quite similar. So the workforce, it's a highly skilled workforce. In localization, most of the people you have, whether they're localization leaders, project managers, or translators, they're master's degree and above. In law firms, of course, most people have JDs or some sort of graduate training. The labor intensity is very, very high. In localization right now, most of the work is done by services bureaus. So you have some automation in terms of workflow and project management, but the actual act of translation itself is very labor intensive. The same for law firms. If you're writing briefs and contracts, that's mostly done manually. The C-level perspective, unfortunately, on these two functions is that they're essential. If you're going to market internationally, you absolutely have to have localization, but most C-level leaders don't view it as strategic. The same way with legal. You certainly need a law firm if you're running a business, and you need legal counsel, but it's not really, most people don't use the law strategically unless they're, I don't know, like a patent troll or something like that. It's just a business function that you have to have as a general order of doing business. Localization is typically outsourced for most businesses. Legal is too, even for the biggest companies. So as a company gets bigger, it'll usually insource things like contracting, but it'll outsource things like complex litigation. Usually it won't do that internally. Localization is really expensive. Legal is super expensive. And then finally, quality is somewhat hard to assess. So it's not the same as evaluating like a product you can buy in a store. With localization, you get translation back. The work product is a translation. Oftentimes you don't speak that language, so you've got to have a LQA framework to assess the work product. In legal, how do you assess whether it's good or not? You get a contract back. It's really hard to tell like whether this document is good or bad. And so the sort of work product that you're paying for is very difficult to assess, and oftentimes you lack either the skills or the expertise to assess it. So for me, when I get work back from our corporate counsel, I don't have a law degree. I mean, I can read it, makes sense to me, but I don't know if it's like the best contract in the world or the worst contract in the world. You kind of don't find out until something goes wrong. Okay, so that's the kind of pedagogical device we're going to use in the rest of the talk. So I'll go for about 20 more minutes talking about that, and then we'll get into questions. Okay, so I'm going to make a few simplifying assumptions in the rest of this talk. I'm going to assume that you don't need an on-premise MT system. If you need to bring the technology on-premise, usually it's not the technology itself that's on the critical path. So typically people make this decision because they're security considerations, data security considerations, and they also maybe have support considerations. And the support considerations are going to be usually significant. It's also the case that most companies, to run like a super large scale production MT system, they just lack the infrastructure to do that. If they have, like a commercial cloud account, like some companies now will be using MT systems like in a commercial cloud, like Amazon or Microsoft or Google, that can work. If you have like an MT system that you can deploy into one of those environments. Most of the open source systems aren't going to be able, they're not designed for that type of infrastructure. So there are very, very few systems that you can buy that you can deploy into a commercial cloud as a sort of on-prem solution that's going to take full advantage of all the AI infrastructure. So using, GPUs, in some cases using specialized hardware for search to make inference run faster. So there are lots of considerations to going into an on-prem MT system that I'm not going to get into here that are totally separate from translation quality. I'm also not going to consider the case where people want to like download an open source system and train it themselves. I think generally this just isn't the best idea. It's really hard to beat a company that has a research team and builds this technology themselves. So it's just, while it's a nice idea that you can, sort of download an open source system and train it yourself, that's really nice. It's just not the case that you're going to be able to beat, like one of the tech companies or a company that really specializes in machine translation training systems yourself. That usually still requires a research team, people with PhDs. The research community is moving really, really quickly, so a lot of your success depends on how quickly you can implement new ideas, and that's hard. Related to that, training data in neural machine translation, the quality of that data is much more important than it was in the old systems. So unless you have a lot of data and it's very high quality, it's just really hard to compete with some of the systems you can buy off the shelf. Okay. So I'm going to consider two scenarios. I'm going to consider scenarios where you want to use raw MT with, with sort of no human in the loop, and where you want to use MT as part of a localization solution. So you're, doing localization as you did before, but now you want to bring in AI and machine learning into what you're doing. So let's talk about both of these, and I'll go through the steps for, at sort of a high level of how you would think about these things, and then I'll relate this back to our sort of legal story of how thinking about localization in MT might relate to how you would bring this into a law firm, which is something I've thought about. So raw MT, the main criterion for when you want to use this in a business setting is if you can tolerate unpredictable errors. Sometimes the MT output is great, sometimes it's not great. If you're in a situation where those unpredictable errors don't really matter, then that's a great setting for raw MT. And really, you just then have to ask yourself as part of your planning phase, do I have some training data to train the system so it's specialized to the domain that I care about? Do I have blind test data? This is really important. By blind, I mean, do you have a set of documents that you're going to translate with the MT system and evaluate the output that you're absolutely certain is not in the training data of the MT system? So usually you do this by having some documents that don't end up on the web somewhere where one of the big commercial systems can pick it up in a web crawl, or that you haven't sent off to an LSP or something like that. So it's a set of data that you're sure hasn't ended up somewhere where somebody could train on it. And then finally, do you know how to run an MT evaluation? Do you know how to score MT output? Do you know how to do significance testing? If you don't know the answers to any of these questions, these are the sorts of things you'd want to figure out as part of planning for an MT deployment. So that's the raw MT setting. That assumes you're going to manage the technology yourself. Now let's say that you're going to evaluate it as part of a localization solution. So you're outsourcing localization to a vendor, and you want to know if they're going to be using AI and machine learning. So really, you're just in a mode where you're going to start asking some questions. And some of the questions I would ask are, how is the use of MT reflected in the pricing? These MT systems are used as decision-making systems and productivity enhancers. So you should expect that there's some influence on pricing, and that's a natural question to ask. Another question to ask is what's your business model with AI and machine learning? What a lot of companies are doing is they just say, oh, we're going to use MT and we're going to give an across-the-board 20% rate discount. And what ends up happening is that just propagates through the supply chain. So one LSP forces the next LSP to take 20%, and then that LSP forces the translator to take 20%, where that number doesn't really come from anywhere. Does it come from, why not 90%? Why not 10%? Why not 0%? That number has to come from some kind of measurement, and it has to be built into the way the business model runs. And that really matters because what can happen these days is if these rate discounts are being enforced, the best translators don't want to work for you, and then that ends up impacting translation quality. You can ask who's building these systems for you. That's really important. Does the company have engineers? Does it have data scientists or any people who are involved in training these systems? A fourth question to ask is an asset being created? These machine translation systems are assets. If they're being built for your business, then they're being built from your data and you can use them. And so you should naturally ask, like, where is this asset and do I get access to it? In much the same way in translation memory days, you would ask, where's my translation memory and do I have access to it? And then as this asset is created, that's going to allow the vendor to increase efficiency over time. And so you should have a plan in place to sort of figure out how that efficiency, whether it's going to be returned to you in some way. Okay, so that's the planning phase. In a lot of my job these days, I spend a lot of time talking to customers. And so, these are the questions that I would ask if I was sort of trying to bring machine translation into my localization function. People tend to ask different questions. And if you think about them in terms of talking to a law firm, it's kind of weird. So I'll go through some of them that I get asked. So some things people will say in the enterprise is, we're thinking of pre-translating with an MT system and giving the vendor the output. And this is the same as sort of if I went to a law firm and I said, we're thinking of writing a rough draft of this brief and we're going to give it to you and let you fix it, which is a little bit strange. Like, no law firm would really let you do that. But that's the equivalent of what doing pre-translation with MT. That's kind of the equivalent. People will say, can you give us 1,000 words of output to evaluate? Which really, like, when you're doing quality evaluations, you need really a large sample. And usually people ask for these small samples because they're limited internally in how much they can evaluate. But you really should, as part of your planning process, you should think about how you can evaluate a significant sample of translation. So this is equivalent to me going to a law firm and I'm gonna, do pages and pages of contracts and maybe financings and litigation with the law firm, but I'm gonna make that buying decision based on looking at a page and a half of output. That seems kind of strange. People will also say, can you give us your baseline MT output, which in production, you're almost always going to be used some sort of domain adapted machine translation. So the baseline just doesn't really matter. That you can think about that as like an intermediate draft. And so that's like going to the law firm and saying, can you give me like the third draft of the contract instead of the final draft of the contract? Like, why do you want to see that intermediate work product? So these are examples of questions that like you shouldn't really ask. And I'm suggesting these are the questions that you really should be asking of a vendor. Okay, so let's get into talking about evaluation. So if you're in the raw MT scenario, the first thing you need to do is select a baseline. And the easiest thing to do is just pick one of the commercial systems as your baseline. So either Google system, Microsoft system, or both fine. You can get an API key with a credit card. That's terrific. You can do that in 5 minutes. And now you've got a baseline system that you can evaluate against. You can train both of these systems with your extent, any existing data that you have. And then you can translate the blind test data that you have for the different domains that you care about. So again, this blind test data are these documents that you're sure haven't been used to train any one of these systems, and they haven't been trained, used to train your vendor systems. And then you just run an evaluation. So this is a really straightforward process. There are books about how to do it. There's lots of information online about how to do it. This is a really well understood process. If you're going to evaluate MT as part of a localization solution, I would suggest that the main thing you want to think about is both scale and translation quality. So that looks like something like evaluating 50 to 100,000 words. And why do you want to do this? Because at a small scale, so if we go back to thinking about, sort of evaluating 1,000 words, you don't really need MT to do that. Like what MT is going to allow you to do is to scale up the production process and make it more efficient. If you're asking a vendor for 1,000 words, they can just, hire, Flaubert or something, or some columnist from the New York Times to just make those 1,000 words great. And you're not really getting at the underlying production process that involves machine translation. So you really need to think about doing a large scale evaluation. That means you need to provide some sort of style guide and text specification, so you're identifying ahead of time what translation quality is. And then you want to sample from the result. You want to randomly sample from the result. It's not realistic to think that you're going to evaluate all 100,000 words, but maybe you're going to take a sample of 10,000 words and run your standard LQA quality evaluation, however you do that. But what that's going to do is that's going to let you see that the vendor can run the solution at large scale, that they can generate output with a machine translation system that's going to match your style guide, and that the final quality is going to match what you expect. And notice here, I don't suggest you ask them to give you the MT output, because actually that doesn't matter. That's just a part of the production process. All you really care about is the final output that you get. So, but that's not the questions that people tend to ask when we talk to them about MT. So things that people will say is, we're going to implement a multi-engine strategy. So they go off when they're evaluating raw MT, and they take like 10 MT systems and they all, sort of evaluate them and compare them. And this is a little bit strange because it doesn't really understand how the research community works, which is that everybody's using roughly the same algorithms. If you want to know which company is using which algorithm, they usually have a paper about it. And these algorithms are sort of shared and discussed in the research community all the time. So it's not a secret what everybody is doing. So this is sort of equivalent to like evaluating a bunch of law firms where the partners all went to the same law school. Like, sure, there's some differences between the law firms, but those differences probably aren't materially significant, and they're really not going to influence your production process. So really, you just need to pick a good baseline system and then evaluate, a system or two, and find which one is the best. And if the differences are like, very small, it just doesn't really matter all that much. So the effort to go through evaluating a bunch of engines just doesn't really make much sense because the differences between them are all very small. Going back again to the small sample size, can you give us 800 words to evaluate? That's just not enough to form any kind of conclusion. It's certainly not enough to conduct a test of statistical significance, which is what you're going to be doing when you're evaluating raw MT. So this, again, is me going to the law firm and asking for a page and a half of contracts to evaluate. It just doesn't make much sense. And then at the, sort of the end of the evaluation, oftentimes you'll get feedback that's like, these translations aren't good, or the output isn't great. And that's really hard. That's a hard statement to make when there's no clear definition of what good is, which is where the style guide and the text specification comes in. So this is like, if my lawyer gives me a brief or a contract and I just say like, this isn't good, it's really hard for me to form that judgment and for the law firm to sort of do any sort of remediation if there's no definition of what good is. So I would say in doing any evaluation, figuring out what good means is the bulk of the work. That's the most important thing to do. Okay, so now implementation, step 3. If we're in the raw MT setting, really the most important thing to do is to collect all the training data you have internally. So this is your existing translation memories. You want to, typically with these newer systems, you want to segment that data in some way. And by segment, I mean break it up into domains. So if you have marketing content and legal content and say software UI strings, instead of training one big system on all 3 of those domains, you'd want to segment your data into those domains and train a specific system for each one. Then you train systems, and then you integrate those systems into your workflows. And actually, this integration part is usually the hardest part. And so significant time should be left for that. So this is connecting the system into a localization stack, or connecting it into like a content repositories, which usually requires external engineering support. Now, if your AI and machine learning solution is part of a broader localization solution, here, I think the word of caution is to ramp the workflows incrementally. So this would mean the different content workflows that you're running, like marketing and say software UI, and also the languages. The reason for this is that most vendors, like this technology is new, so most vendors are new to MT as well. And ramping up to production, a new production process with a new style guide, a new set of terminology, and a new set of quality requirements is hard for everybody right now. So you want to take kind of an incremental approach to ramping up the new solution, realizing that really translators are the critical link. So bringing in automation is going to change fundamentally the way that translators work, and people struggle. Most people don't like change. And so changing the way people work, as most of you know from running teams and running businesses, that's one of the hardest things you can do, is change the way people work. And so you should recognize that bringing this automation and this tooling into the translation workflow, somewhere down there in the supply chain, there's somebody who's having to change fundamentally the way they work. And that's really hard. But as far as doing the evaluation on your end, really you just implement sampling, some sort of LQA process as usual. There's really nothing different that you need to do. You just need to take into account, if you're bringing automation into a workflow, the temptation of people to just accept the MT output is high. That's called priming. People just sort of take the solution that's given to them. And so you need to be extra sensitive in your QA process. Okay, so production, this is the last phase. Now we've got our solution integrated and we're off and running. And really this is just about quality monitoring. So if you're running raw MT, you're going to be doing sampling, quality monitoring. If it's real-time MT training, so there's systems now like our system that will learn as it's used, you want to do quality monitoring regularly on some interval. If it's a static MT system, so you retrain it from time to time, then you want to run QA every time you retrain the MT system. And then stay current, stay up to date on what's going on, because the research is moving really, really quickly right now, and systems are getting better all the time. If it's part of a localization asset, once you're in production, you just run your LQA as usual. And so just make sure you get access to your asset, which is the trained system that the vendor is using, and don't ask for the MT output. It's actually not terribly important. It's part of the production process that's being run internally, but really all you care about is the work product that's coming out the final phase of the factory, and so you just run your LQA process as usual. Okay, just 2 more slides and then we'll go to questions. So where my analogy breaks down is that localization is just absolutely moving from a sort of a labor-intensive industry to one of high capital and software intensity. So these systems are coming in, they really work well. Companies are having to retool to deploy and train people to use these systems, and software and technology are just absolutely going to be a bigger part of the job. That means that for companies that are using MT, new technical expertise and skills are going to be required, and that's not actually true for legal. There's no technological breakthrough on the horizon that's really going to make lawyers that much more efficient or that much more effective in the next few years. That's not true for localization. The technology is definitely ready and it's changing the way that people work. The second thing that's different is that, which is good for us, which is that localization can and should be a growth driver. Going into new markets should be accretive to revenue. And for the best companies, localization is a growth driver. Making it great and providing a customer experience for people in their own language is definitely a driver for growth. And legal will almost always be a cost center, with the exception of very idiosyncratic businesses like patent trolls. Legal's a necessary business function, but it's not something that you use to grow your business. So those are good signs for the future of localization. It's getting much more efficient, it's getting much more technical, and it can be a growth driver. So as the cost goes down and the scale goes up, companies are more and more going to be able to use it to drive international growth. Okay. So let me conclude with this. My background as a researcher, we started the company, and so I said more and more my job is managing a business and talking and working with customers. But I still sort of have, sort of one half of my body in the research community and one half of it in sort of practice. And so this is actually a slide from a talk that I gave last night at a meetup here in San Francisco that people, there were a lot of questions about. So I'm going to just go over it briefly here, and then we'll go to questions. So here are some things that people say when I'm sort of out in the world talking to them about machine translation. People say, like, we're evaluating the best engine for a certain content type. Well, we have systems, as I said, everybody's roughly using the same algorithms, and we now have systems that will adapt to content types as they're used. So really what you should be thinking about is, what's your data segmentation strategy? If you're piling all of your data into a single translation management system without any sort of labeling or segmentation, that's really going to hurt you when it comes to MT training, because the best systems can be trained when you segment your data into different domains. So I would suggest that any effort that's going into sort of evaluating different engines, that effort is better reallocated toward thinking about data segmentation. People will say, we're evaluating MT on some low-value workflow that nobody cares about, but actually MT is really going to take the place of translation memory as the core tool that people use to do localization. And just like TM touches every word that goes through the industry right now, in the next couple of years, MT is going to be touching every word, not as a replacement for what localization vendors do, but as a tool to make them more effective. And so MT is going to be touching everything, and so you should be thinking about, what's my strategy for bringing MT into every word that goes through my localization workflow. People will say, we're asking our vendor for 20% discount. Well, where does this number come from? Why not 5%? Why not 90%? Really what you should be thinking about is, how are you going to monetize these efficiencies that come from the deployment of technology? And that, again, is incumbent on the executive to sort of think about, how is that going to work and what's my plan for that? And then finally, people will sort of, this is another case of sort of dipping your toe in the water. We're going to add an engine into our, sort of our legacy TMS stack. Well, most, sort of TMSs, they have this very narrow connector into MT, but these MT systems can do all kinds of really interesting things. They can do tag placement, they can do, they can adhere to terminology, they can do online learning and adapt as they're used. And so you really need to start thinking about, how does the localization stack change so that it's sort of designed around MT, which is going to be the core component of what's going to be used to do localization in the future. Okay, so with that, I will conclude, And thanks for attending today, and I would love to take your questions.
Thank you, Spence. I felt that comparison with the legal domain was really helpful, and especially with regard to where that comparison breaks down. So it's really, really interesting to listen to. We have a couple of questions. Let me start you off with one that I think may be going a little deeper, and that is, you mentioned that statistical machine translation lacked knowledge of language and also real-world knowledge, and that neural machine translation to some extent is bringing that back. We're beginning to learn that. But that also existed in the old rule-based models that we used to have, because those were encoded by knowledgeable humans. So that technology has been on the shelf for 20 years. Do you see any opportunity to leverage this knowledge again in machine learning in an NMT? And the reference here is being made to Sistran, who's beginning to do that. What's your take?
Yeah, that's a provocative question. So I want to clarify one point. So the neural machine translation systems, they don't really incorporate world knowledge or common sense reasoning. What they are they're better models of language. So they are able to better represent morphology, and in some cases, although they don't do it explicitly, they're able to represent syntax better than the old statistical systems. It is definitely true that the rule-based systems of 30 years ago or so, these were called knowledge-intensive systems. So these were written by people, and people could, sort of incorporate more information into these systems than we presently do with these neural MT systems, which are really just trained off of data. All they're trained off of is source sentences and their translations. So I think more generally in artificial intelligence and machine learning, we know that we as humans are capable of sort of reasoning about the world, and these systems can't really do that. So that's kind of an open question, not just for machine translation, but just across AI generally, is how to incorporate common sense reasoning and some elements of world knowledge into the systems that we built.
Mm-hmm. Cool. What's your outlook for neural machine translation for more exotic languages where we have a lot less training data?
Yeah, so that's really interesting. I think you could, so I spent a lot of time when I was in grad school working on English to Arabic systems, and the statistical systems were just really horrible because even though we have a lot of data for that language pair, Arabic is a morphologically very rich language, and so you have these languages like German that have these very complicated word compounds and complex morphology. You have languages like Turkish and Finnish that have, agglutinative morphology, and you've got these really long words with all these different inflections and declensions and so on. And the new neural MT systems actually operate at the subword level, so they're able to model pieces of words. And so the improvements for these languages have actually been better than, say, for languages like French and English, where the statistical systems were actually, pretty good. And the gains with neural MT haven't been as significant as they have been for some of the more morphologically complex languages or languages for which we have very little data.
Mm-hmm. Thanks for that. We have a question here that I think there's a few questions around this. So let me ask it in this way here. Do you have any suggestions for how you can calculate the gain in efficiency for an MT system in the localization process? So you mentioned, you need to decide, is it 90% of the full amount, or is it only 5%? How would you go about? And this is germane to a lot of people who are buying localization services. How should they assess this? How should they approach this conversation?
I think really the best idea that I have for that is measuring, how quickly people are working. So it's been a topic in the translator community for a long time to go to like per hour pricing. And if you start to think about that, then it's to your advantage to help people produce more per hour. In the per word model, there's not really any incentive to translate to be more efficient, because you're going to be paid the same amount whether it takes you a day to translate a word or a second. So you've got to start to think about how the business model changes.
Mm-hmm. And here's one more somewhat concrete question, and that is around enforcing specific terminology within an NMT system. How can that be done well?
Yeah, there's a lot of research on that, and there are systems that do it. Our system does it. I think there are a couple other the commercial systems that do it. So this is called terminology constrained decoding, and so you can take like a term base, put it into a neural MT system, and as it's generating translations, it will consult the term base and generate translation that adheres to the term base. There are systems that already do that.
Mm-hmm. Yeah. And then just to end it up here, one more question here around, this is a well-known phenomenon, that the output of neuro-machine translation is very fluent. It reads well, but it happens to not be a correct rendering of the source. And so one question is sort of holding this position, well, doesn't that increase the workload of the translator?
It can. Yeah, sure, it can. I think it's a different error category. Whereas the old systems, like the statistical systems, they would, get inflections and like morphological agreement wrong, and they would sort of get reordering wrong. The translator would spend a bunch of time fixing word order. Now almost the errors are more subtle. Neural MT systems can make words up that look like words but aren't actually words. They can drop pieces of the source sort of inexplicably. They can add things that don't appear in the source. And so it's just a different set of errors that the translator needs to be aware of.
Yeah, cool. Thank you, Spence. This is really all that we have time for. So thanks for taking time out of your really busy schedule to give us this executive overview here today of Neural MT. And another big thank you for all of our participants for joining us today. We would really appreciate it if you could take just a minute to give us your feedback on today's session using the post-event survey. It is short, but your perspectives really help us to continue to refine our webinar program. And with that, I wish you all a good day or a good night, depending on where you are, and I look forward to seeing you at another GALA webinar soon. Thank you and goodbye.